Hi everybody. Today we are going to discuss about the three basic propagation mechanism. So we already discussed the propagation mechanism plays major role. So in that mobile radio propagation, the basic propagation mechanism is also very important. So how we propagate? Propagate is nothing but a transmission. How we transmit the information from one place to other place, that is a transmitter to receiver. So mainly we are using the radio waves, that is electromagnetic signals. So we can transfer from the frequency range of 0.0012, that's extremely terahertz range, that is 10 to the power of 16 hertz range we can transmit. So the wavelength range is 3 into 10 to the power of minus 8 meter to 3 into 10 to the power of 11 meters we can possible, that is 3 into 10 to the power of minus 8 to 3 into 10 to the power of 11, the range of wavelength is possible. So such a huge wavelength can possible to transmit the radio waves. So the radio waves comprises the both electric and magnetic fields. So with the help of the electric and the magnetic field only, the EMF will be possible. So these are the frequency ranges, the classification ranges. That is ELF, extremely low frequency range, that is less than 3 kilohertz range to 30 to 300 gigahertz, and that's extremely high frequency range. It's these bands. So the wavelength range we can, that is greater than 100 kilometer to greater than 1 millimeter to 1 centimeter. The frequency range is high now, automatically the wavelength range is minimum. So the frequency range is low now, automatically the distance, the transmission distance is high. So these are the main things. So we mainly use the medium frequency and high frequency and all we can use for the commercial applications, and then some special application we can use ultra high frequency ranges. So military application also we can use for the other some special applications. So and then classification of radio waves we have, that is a VLF, LF and MF we can see, we already seen. So like satellite communication and ship communication we are used for the very low frequency ranges, and then the low frequency ranges like mobile communication, and then medium frequency and high frequency range you can for the television communication and the radio communication ranges, and also the very high frequency, ultra high frequency used for the satellite communication, satellite TV and all. So extremely high frequency mainly used for the transponders, there is a satellite communication, there is uplink and downlink frequencies, gigahertz ranges we can use for the transponder ranges. So this is a propagation mechanism, that is LOS propagation, reflection, diffraction and scattering. These are the main thing. So LOS, line of sight, is nothing but the direct path, that is one host to another host, that is same line, that is a line of sight, transmitter to receiver without any obstacles we can transmit the line of sight, that is line of propagation. Reflection in the sense it will reach the particular destination, particular part of the destination, and then reflect to some other direction, that is a reflection. Diffraction in the sense it will diffract, we have more than one, like a diffractor. It's like also the reflection, it will diffract from the one place to other. Scattered in the sense like it is also type. The scattering is on another, it will send to the another direction, the transmitter to receiver will send to the transmitter. Imagine here the transmitter is like you have, and then reflection building you have, diffraction building is there, and then scattering, the tree is there. So we have transmit the signal from one to another, but LOS only that probably send the proper communication. So LOS is major role for the wireless communication. So FOM radio, microwave antenna, satellite transmission and all used for the line of sight communications. Okay, it's all the main important thing of line of sight communication. So the reflection, so the reflection is the interface between the two dissimilar media. So not a similar media, it's a dissimilar media. So we can go for the reflection method. So we want the front returns to the other medium from the one to another. So automatically it sent to the another. So best one is the digital TVs. So once we transfer that information from the earth station to satellite, they receive the signal from the satellite to antenna. That antenna is given to the digital TV. So these are the main thing of things. So we may use it in the hill station and other areas. So like a river, seas areas. So we can see. So we can use for the reflections. Diffraction is nothing but it is a single edge or edge corner. So encountered in the edge corners. So like what we saw in the that building, first one. So there is a corner of the building, so diffraction will take places. So the size is larger than the wavelength. So the signal is example for this signal. So very larger comparably the other one. So automatically its secondary source are redirecting or re-radiating into the shadow region. So shadow region, so there is other end of the medium, so we can automatically go for the diffraction method. The scattering method is nothing but the signals encounter a small object of a size of smaller than the wavelength. So smaller size or smaller wavelength, it will be obstacle. So we can go for this scattering method. So automatically it will scatter the signals. So this is a multipath propagation what we see in the first slide. So it's interaction method, how it will transmit. So it's a small scale fading. So fading is also important thing. So small scale fading is concerned with the rapid fluctuations of received signal strength over a very short distance or short time period. So fading is occur very short period, very short distance only it will able to occur. So remaining time it will automatically transfer. It depend upon the propagation environment. So environment also plays a major role for the wireless communication. So large scale fading. So large scale fading occur like a more number of times. So between the transmitter and receiver, it related to large fluctuations in the signal over the distance. So large fluctuation occur, that large scale fading will be possible. It includes the path loss also, it's available in the large scale fading. So these are all the important things in the fading technologies what were used in the communications. Thank you.